In the previous lesson, we looked at measures of central tendency, mean, median, and mode. Those are useful numbers to know, but another thing that's useful to know is how spread out the data are. And this is where we talk about measures of spread. So we're looking at how spread out from the center is most of your data. Is it closely clumped to the center, or is it really spread out far? So the first thing I want to talk about is something called quartiles. So quartiles divide the set of data into 4 equal intervals. You're dividing your entire set of data into 4 quartiles. So there's 3 values. There's Q1, Q2, and Q3. Now that value Q2 is the median. So in the previous lesson, we looked at finding the median. And there's different terms here that I'm going to use. The first one is range. Range is just the difference between the greatest and the least values in the data set. So the difference between your maximum and your minimum. It tells you how spread out the data is from the lowest value to the highest value. Then there's something called the interquartile range, and that's the difference between your first and third quartiles. I'll illustrate that in a minute once I show some examples. And the last thing is more of a visual representation of all of this stuff that I've talked about, quartiles and maximum and minimum. And it's a box and whisker plot. So this is a type of a graph, and it represents all of your quartiles with a box, and then the maximum and minimum values look like whiskers. So all of this is new. I'll illustrate it with some examples, and hopefully it'll make a little bit more sense after that. So here I have 21 different test scores, and I've already arranged them from lowest to highest in order. So we're going to determine the quartiles, the range, and the interquartile range. Once we've done that, we're going to draw a box and whisker plot. So I'm going to illustrate all those things that I showed you previously, and just kind of illustrate them here. So the first thing we want to do is determine our quartiles. So the way we do it is first we find the median. The median is the exact middle of our list. So there I have my median. I have an equal number of values on either side of the median. So the median is the point of symmetry on my list. Now remember from before, the median is the second quartile, so Q2 is equal to 69. Now to find the first and the third quartile, now I have to look at this list, this half of the list, and just find the median of that half of the list. It ends up being right in between these two values. So it's between 59 and 59, so the first quartile, or Q1, is just 59. If I look on the second half of the list, I have to find the median of that part. It ends up being right in between 79 and 80. So my third quartile, Q3, is 79.5. I'm going to find my interquartile range right now. And the interquartile range is the range from my first quartile to my third quartile. So if I just take the difference between Q3 and Q1, I'll get the interquartile range. So it ends up being 20.5. That means there's a difference of 20.5 between the first and the third quartile. Now the range, I'm doing pretty much the same thing, except this time it's the range from my lowest to my highest. So if I take my maximum value and subtract my minimum value, I'll end up with my range. For this, it ends up being 42. So now that I've done all these calculations, I'm going to draw a box and whisker plot. I'm going to draw that down here. So the first thing you want to do is make a scale for your results along the bottom. So remember, these are test scores. So I'm going to make a scale for all of my test scores. And now I'm going to draw on all of my quartiles. So my Q1 is 59, Q2 is 69, Q3 is 79.5. So once I have all those, I'd make it into a box, and my maximum and my minimum values become the whiskers. So now this is what your box and whisker plot looks like. So this is just a way to visualize where most of the values lie in your set of data. So range and interquartile range are useful measures of spread. They tell you how spread out the data are, but there's some more. There's variance and standard deviation. And these are numbers which assign a value to the spread of the data. Basically, if the value is large, that means the values are spread far from the mean. If the value is small, that means the data are closely clumped around the mean. There's formulas for these too. Here's the one for variance. It looks complicated. Basically what x1, x2, x3 represent are the first number in your list, the second number in your list, the third number in your list, etc. until you're done. So you would take the difference between the number in your list and the mean. Whatever that difference is, you'd square it. You do it for each item in your list. You'd add all those together and divide by the number of values in your list. So that's tedious work. It's not hard work, it's just tedious to calculate variance. So I'm not really going to make you calculate variance by hand. If you ever need to calculate variance, there are statistics calculators for that. What you really need to know is this one here. So maybe write that one down, put a star on it. You need to know how to calculate standard deviation, and it's just the square root of the variance. So if you have the variance, all you have to do is take the square root and you'll end up with standard deviation. And so just remember, the larger the value, the more spread out from the mean your values are, and the smaller that your value, the more closely they are clumped together around the mean. Here's an example. Bob works part-time selling synthetic hairballs for ceramic cats. He recorded the number of hairballs sold at nursing homes each month for the last 12 months. So here we have the number of hairballs sold each month. Find the median, first quartile, third quartile, interquartile range, and display the data in a box and whisker plot. Now I've given this reference here. This is an online statistics calculator that you can use to check your work. So why don't you pause the video and try this, and then you can unpause the video and check with what I have. Once you do it, you should get something like this. You should get the first quartile is 15, the median is 32, and the third quartile is 46. Your lowest value is 6, your highest value is 62, so your box and whisker plot should look like this. Here's another one. Bob's monthly gasoline expenses in dollars for the past year are shown. So that's how much he spent on gas every month. Calculate the range and the mean. So why don't you go ahead and try that? Pause the video and see how you do. So you should end up with a range of 29 and a mean of $75.40. If you were to use an online statistics calculator, you would see that the variance is 84.57. So typically, all you have to do is type in the list of numbers and then it'll calculate this for you. Okay, so that's the variance. Calculate the standard deviation. And what does it mean in the context of the question? So try to calculate it first, see if you can come up with what it means, and then check back in here. So the standard deviation is just the square root of the variance. We already know what that is, so we can just find the square root of 84.57 and we get 9.19. But what does it mean in the context of the question? Well, we're talking about Bob's gas expenses, so Bob's gas expenses were mostly within $9.19 of the mean. The mean was $75.40, so most of the expenses were within this amount of that. They were either $9.19 higher or lower than that, on average. A company must choose between two manufacturers for bolts, Caninco and Qualitech. They both have the same mean length of 72 millimeters. So that just means on average, both companies make the same length of bolt. However, the standard deviations are different. Caninco has a standard deviation of 2 millimeters. Qualitech has a standard deviation of 0.1 millimeter. So which manufacturer should the company choose and why? Well, Qualitech has a lower standard deviation. That means most of their bolts are only within 0.1 millimeter of this 72. Caninco has a higher standard deviation, so most of their bolts are within 2 millimeters of this. So just to put things into perspective, you could have bolts that are 70 millimeters or 74 millimeters long. That's a big difference. Over here, you could have bolts that are 71.9 or 72.1 millimeters. That's more consistent, so we would choose Qualitech because of that. Can the range of a set of data be zero? Think about it. If so, what would this indicate about the interquartile range, the variance, and the standard deviation? Give an example. Well, it is possible to have a range of zero. Range is just the difference between your highest and lowest numbers. So if your lowest number, your minimum, and your highest number, your maximum, are the same, then you would have a range of zero. So here's an example. In this list of numbers, all my values are the same. So the range would be the difference between my lowest and my highest number. It's zero. The range is zero. So the variance and the standard deviation are all zero because there is no deviation from the mean. The mean is 5. There is no deviation from that. So at this point, all you want to do is understand the terminology, keeping in mind that this is going to be open book for any quizzes on this, and you can look it up. Once you know the terminology, you just need to know how to apply it. So you need to know what measures of spread mean, and you need to know how to draw box and whisker plots. So try the practice questions. If you run into issues, please let me know so I can do my best to help.